Welcome to Ask and Learn.
All right, here we're being asked to verify that the function f satisfies the three hypotheses of Rolle's theorem on the given interval, and then we're being asked to find the number c's that satisfies the conclusion for Rolle's theorem. So here the function is sine of x over 2 on the closed interval from pi over 2 to 3 pi over 2. And so now to recall that the three conditions of Rolle's theorem is continuity on the closed interval from a to b, differentiability on the open interval from a to b, and the endpoints must equal each other on the function. So f of a equals f of b. So trigonometric functions are all continuous. So we know that this is a given. They're also all differentiable on a closed interval. And since we are on an interval, we know that this is also, it doesn't have to be on an interval. It is differentiable everywhere because it is a smooth function. So those are properties of trigonometric function. And the last point, f of a equals f of b, we have to actually figure those out. So if we plug in the values f of pi over 2 into our function sine of x over 2, we actually get root 2 over 2. And if you do it again for 3 pi over 2, you also get root 2 over 2. So we know that this last condition is also satisfied. So once these three conditions are satisfied, we know that there is a c that satisfies the conclusion to Rolle's theorem, and the conclusion is there is a c such that the derivative f prime of c is equal to 0. So all we have to do is we can actually find these numbers c by setting the derivative of this function equal to 0. So if we take the derivative of f prime of x, we actually have to apply the chain rule. We have to do the inside derivative times the outside derivative, keeping the same inside. So the derivative of x over 2 is 1/2. And the derivative of sine is cosine. So we keep cosine. And then we keep the inside the same. And all we do now is set this function equal to 0. And since this is a trigonometric function, we know that the cosine function equals 0, just the cosine function equals 0 when it is at pi over 2. So we want to find the values where x over 2 is equal to pi over 2. And since cosine is a periodic function, we know that it is a pi periodic function, so we're going to add k pi. So k is any integer number, from any any integer number, so it could be -1, 2, 1, 2, 3, 4, 5, etc. So if you solve for x, you get x is equal to pi. When you multiply 2 on both sides, you get x equals pi plus 2k pi. And since our interval is only from pi over 2 to 3 pi over 2, the only number that actually satisfies lays in this interval is actually just pi. So x is equal to pi, because since our function is telling us that it has to be 2k pi period, according to the way our function is set up. So the next point in which we will get a value of 0 is when we are at k equals 1, so that'll be 2 pi, it'll be 3 pi, and 3 pi is not in our interval. So the only interval that lies is when x is equal to pi. And so this is the c that gives us f prime of x equals 0.